Okay, right. Okay, exam. So starting point is always the wiki, right? Wiki, there's now an exam page, and it's also linked on the main page, so you'll be able to find it. If you don't find it, then yeah, you're in trouble. So the idea is here we have instructions, associated necessary resources, and submission area, and an oral exam area, which is probably still to be updated. We'll see about this. So what's the idea? The idea is that you will have a somewhat interesting task of loading a height map and rendering it, of course, right? So to provide presentable output, you don't need to texture that surface, but you need to provide color information. The idea is that we resemble a landscape scene in which you will need to introduce altitudinal zones, right? You know those from those maps, that you have different altitudinal zones, for example, snow zone, vegetative zone, and so on. And that's something you are then supposed to do with the data that I'm giving you. And the data will be a height map in the form of a PNG file. Let's bring that up. And it, of course, is available in the resources section. I'll just show it to you.
So we're doing a mesh terrain or like a cube terrain?
Mesh. No cubes. So the contrast is a bit poor, but you will see it better. The idea is there that you have a PNG file that is basically a height map, right? So you have different shades of gray, the darkest one representing the lowest area, and the brightest one the highest area, right? So in this terrain. So you kind of need to render it and maintain the XY coordinates somewhere. Accuracy is secondary, right? So it's obviously terrain, perhaps it's even terrain or area, but that doesn't matter because I'm appealing to, it's a wicked problem. So you need to have a sensible rendering of the scene, right? So you need to decide, okay, how far you want to, how much elevation you want to introduce, but depending on the color coding. But as long as we see the intuition of your modeling, then that's fine, right? So you are then supposed to introduce 4 altitudinal zones, starting with water. Assume that everything that's black, actually we need to shut off the light, but you notice that everything that's the darkest shade of gray, if you want, or black, is considered water. That's an assumption you can make, right? So nothing is below water level, and the idea is that we color code it, and let's say water, which color do we usually ascribe to water?
Yellow.
Yellow, good. Okay, let's start with that. Let's refine that. Any other ideas?
Swamp green.
Swamp green, okay. Yeah, we can vote on that. So I wouldn't even, if you're technically so keen in introducing that and you argue your choice and document it, you probably get away with this. Anyway, the lowest level is water, then followed by a vegetative zone. Like the idea was to make it green typically in maps, and then a brown zone, and possibly a snow zone, which is, any color intuitions there?
Black.
Ah, black, okay, we get there.
Magenta, obviously.
Okay.
Yes.
I would suffer with you guys. I don't know. So my intuitions were a bit harsher than that, but let's say you can play that out. So you render the scene, and that's basically the first idea. So now you can look what I told you to do there as well. Of course, you can actually start looking at this yourself. I give you afterwards a few minutes to actually read and ask questions regarding this. So I wanted to talk this one. Yes. So the issue there is, of course, if you're saying, well, I'm using multiple colors, right? So 4 zones. The obvious intuition is let's do just an interpolation from blue to white, let's say, right, across the entire range, right? But the idea, we still want to see those zones explicitly, right? So we don't want to have hard boundaries. So you're switching between blue and green, but actually you want to kind of smoothen, soften that, or introduce some sort of softening mechanism to indicate the boundaries, but keeping the zones distinguishable, right? So it's clearly distinguishable zones. Does that make sense, or did I lose everyone?
That makes sense.
Right, cool, okay, no surprises there. And of course, to debug it, we want to see contour lines, right? So there's certain keys, a lot of keys in fact, that we introduced that we will use for debug purposes. So the idea is that we want to show the contours, where the boundaries are, in case we don't spot them based on your choice of transition. Yeah?
Oh, should we Like, does that have to be marked on the mesh, or can just mark that with, say, another object? Like, this is where it's supposed to go?
No, like if you're modeling a scene, right? So you again, you know from geography or from geovisualizations, you know those contour lines, right? There's elevation lines that indicate altitude levels.
Oh,
right?
okay.
So and you basically mark the boundary hard by whatever. Probably black seems to be a sensible choice, or depending on the contrast, white or whatever else. Anyway, so we can debug that you actually identify the boundaries, right? So so whether or not we interpret your transitions of the zones correctly, because I could imagine that this could be hard at times, depending on the choice or range of interpolation you choose. And on top of that, of course, we want to have a free-moving camera. So, free-look camera kind of thing. So you should be able to navigate in this area and explore it to some extent. And again, there are some keys attached to the functionality that you want to that we want to have, right? Moving the camera, using keys, and zooming as well, right? So no surprises there, I hope. So this was the easy bit. Now, the idea is there to bring some life into the whole scene, right? As opposed to just having this scene, is that you will introduce a seasonal change, depending on the season, basically, that will change the altitude in the zones. How realistic it is a different question, but let's say that in winter there's probably the snow zone is more dominant and actually suppresses most of the other zones, right? So you have a shift towards a snow-centric scenery, and in summertime it's quite the opposite, where the snow retreats and it's entirely green or brown or whatever else, right? So not in all cases. Again, we apply to your intuition there. Let's be inspired by your environment, for example. You may not always have snow throughout the year, right? So yes, but in winter you may perhaps even not be able to see any brown area, because that's most likely completely snow covered, or perhaps even the vegetation area. So the idea is that you model this over an entire cycle, seasonal cycle, right? So the usual 4 seasons. In Jorvik it's 2 seasons, but generally you get the intuitions, right? So yep, that's the idea. And to debug it again, we like debugging. On top left, please tell us which season you think you're currently showing, so we can actually retrace your intuitions, because it's kind of very soft in a way, because we leave you a great amount of freedom here to implement it and argue your point, which is fine, right? So as long as it makes sense. By default, the seasonal change should be automated, so it's an element of timing in there, I suspect. But you should also be able to, again, for debug purposes, to switch between seasons, just to look at spring, just at winter, or whatever else. Yeah. So, but by default, it would be automated. All right. If you're still not bored at that, then there's more to do. So, in addition to the seasonal cycle, we also want to have a daylight cycle. However, this can be independent of the seasonal cycle. So you have a given season situation, spring, let's say, and you show me one day, basically an entire daylight cycle, if you like. Why are we doing this? Why do we have this daylight cycle? Most likely?
Show the lighting.
Exactly, right? So, So that's the key idea here. We want to differentiate, see that you understand all the different features and can use them independently. And that's the same thing here. So same pattern, but you actually have some sort of light, let's say. Sun, don't know. That traverses the scene, and you need to decide how to model that and make some calls with regards to that. Same issue, same situation. It should be automated by default, but we would want to be able to debug different stages as well. So, good. That's the baseline for the task 1. Yeah? Any questions so far? Any confusion I may have left? I actually still somewhat mentally in some G++ problem, but right now I'm slowly recovering from that. So if I forgot anything, if I forgot to explain anything somewhat intuitively, let me know now. Good, no surprises there. So if you want to go beyond this, some intuitions. Of course, sky's the limit, right? So, but actually literally in that kind of example, you can actually do a lot in the sky there if you want to. But so that's good, right? So if you want 1A, you need to kind of do something that we didn't expect anyway. But we give some intuitions here as to what you can introduced to make the, you know, to beef up the feature set. So you can actually combine daylight, seasonal cycle and daylight cycle, right? So you traverse over the seasons and considering daylight cycles. How realistic is the question? We don't have 365 iterations, most likely, but you could, you know, motivate some relationship between those two. One thing you could do is, for example, have smooth transitions between seasons. So if I press the button 1, 2, 3, 4, I don't have a harsh shift between the different seasons, but actually you have some sort of animation effect in there if you like. This is a nice one. If you have gone to Mimosa lately, but you haven't because you're busy students in May, you don't see those things. Actually, water level is slowly rising again right after winter. It has been retreating considerably. Yes, no, lake, no. Okay, but anyway, so you know that's the usual pattern, right? So you have an ice layer forming and then water retreats. Now water's coming back, right, because of spring, right? So if you want to play with this around, it's good as well. Tricky, however, is to have retreating water because you don't know the surface under the contour that I showed you, right? So then you would need to guess, which is probably not sensible. But we could perhaps model rising water levels. But again, that's all top of it. So if you want to do any additional shading and subdivision and smoothing, go for it. Shadows, if you want to introduce some artifacts like trees, good morning, you can do that as well. Clouds, so we leave that all up to you. So there's a lot of space for you to explore. However, I strongly recommend you to focus on the essential tasks first before exploring further. Task 2. Yes, so we want to do something with that scene, right? Other than just flying around having a look. And that is, yes, we want to fly around in the scene. So, I provide you with a glider model, which I got from a modeling website, quite straightforward, but I think it's quite sensible in terms of its feature set and so on, and that you're supposed to model that, right? So, load and embed in your scene, make controller using the WASD keys as usual, and basically represent a flying motion of an airplane, and then we can to some extent control it. And that's pretty much it. They have some camera options with regards to that. Should be able to lock the camera behind the plane as opposed to into the scene. And yes, you want to show some sort of lighting effects on the model itself, right? So else we have little...
What do you mean locking the camera to the plane?
Well, yeah, you have a plane, right? So when you're locking in a third person behind the plane, so you basically follow the plane while controlling it.
Are you talking about like orbital controls?
Sorry?
Are you talking about like orbital controls where you're locked to the center of the world and orbit around it?
No, where you're locked to the object. So you're locking to the plane.
Like a mesh?
Like a sun.
Locking to the
You go
objects.
around.
There's always a mesh involved.
Again, like the terrain mesh?
No, you're following the plane. As in airplane, as in glider.
Driving.
Yes, yeah, that's good, thank you.
Easy.
So flying, let's say, yes. But you basically lock into that model, right? So as opposed to the scene mesh, right? I should disambiguate it. I call it glider here, so it probably makes it easier. So you can follow it, or just have a, fix it to your scene as you would do otherwise. So that's the idea there. And of course, you can make that thing more realistic if you want by introducing gravity or physical effects. But again, we're not into modeling realistic physics engines, so you may not actually get so far. But again, follow into if you get to that stage and want to have some intuitive physics that you want to introduce, like acceleration upon dive or deceleration upon when gaining height, for example, you can just introduce that as well. Again, choice is all yours. So and this is about, that's roughly that. Okay, so explicit disclaimer, read this thing carefully first, and the important thing is core features before additional features. I know by experience that there are people that are more inclined to drift off into interesting focal areas and work on those and refine those explicitly. But in this exam, it's primarily about satisfying baseline requirements first before becoming overly complicated, because most likely it will get complicated once you get into those very special areas, right? So, but of course, if you want to, if you're aiming for higher marks, or if you're done early and stuff like that, of course, you would want to attend to the additional features, right? So having a baseline requirement is a solid C. That's the intuition of the marking. Having any of the additional features will point you towards a B, and having something that we have no clue what you did, that's definitely an AA. But if you did something, we have a clue what you did, but we didn't think about it, that's also an A. So does it make sense? So the idea you should want to display independence in your ability to develop things, right? Without guidance. Professionalism, of course, I mentioned that in class last time already, so there's a certain expectation with respect to your code, right? So how you approach that and what you deliver is fundamentally your choice, but we expect some sort of readable code that we actually can understand, right? So, that runs as well. You want to document your deployment. If you don't manage to automate it, which is desirable, meaning the automation is desirable, not managing, then please document how we would deploy it as well, right? So at least some sort of documentation. You need to start somewhere. And if you introduce additional stuff, of course, please document it as well. The README MD on any wiki is probably a good starting point of doing that, right? So because we'll see that immediately once we look at your wiki. Once doing the exam, we expect frequent commits generally, and mostly to see that you're actually active and not just dumping a massive amount of code into the repository at the 5 minutes before deadline. So the idea is to have at least roughly 1 hour per 1 commit per working hour. Of more is, desirable, but just to give you some sort of rule of thumb, that's probably sensible, right? We don't expect to push to that repo, but to commit to your local repository, right? Which makes sense for you as well, right? So in order to be able to be a bit more experimental when necessary. Issue tracker will be used for communication throughout the exam. The idea is there to maintain fairness, right? Everyone sees the same thing and gets all the answers to potential questions. Please attach the label exam, because it makes it a lot easier to subscribe to it, but also to identify it and differentiate it from other issues. Because we wouldn't prevent you from using the issue tracker for other aspects that are not like core exam related, but other means of exchanging information. Again, I can just point you to the issue tracker. The closed issues are super helpful with respect especially to the literature they point to. Very applicable in this context. The resources are available via the wiki page here linked again, the wiki page, and literally only include this map I just showed you plus the glider model. Deliverables, right, that's the interesting bit for me. On Monday at 12 or at noon time, we expect you to deliver a few items. So we have 3 deliverables of this in this exam. Number 1, surprise, surprise, the actual repository, right? So that's the easy bit. Number 2, a self-assessment form, because we want to know what you did and what you didn't do, and also what you think you did, and we'll actually see if you did it. And if you have, for example, bugs that you can't solve, indicate that you're aware of them. That shows us, okay, he's actually aware of those issues, even though he couldn't solve them, right? So that's also a reflection task that we otherwise wouldn't be able to indicate, because we need to somehow get it out of you to figure out whether you actually knew that there was an issue with your code or not. Yeah. So feel free to have a look at this one as well. Should you get it wrong or whatever else, you can submit twice using the self-assessment form. We would use the later submission. Yeah, so in case I wanted to add something, I forgot, I closed my browser. Submit again is fine, we'll look for the latest identifier. Important, however, please, that's how we operate, please use your, I'm streaming this right now, so I can't say, use your student login identifier, right? Not the student number, this number, which is not identifiable, but we will operate primarily on your login, right? So not your full name, not some fake names, not your favorite pet, I don't know, something that's identifiable throughout the course, which we always do. So please be clear about this in this form as well. Finally, we want to have a kind of a video of what you actually did. So you present us in some video form what you actually produce. Think about it like a walkthrough if you like, or you want to highlight specific features, and vlog. Right? So, however, this can take time, of course. The idea is the deadlines correspond to that. So for deliverable 1 and 2, those 2 ones, we expect you to submit it at the deadline of, at the expected deadline. However, for the video you get 12 hours more. And simply because, yeah, whatever. I mean, you can, you know, have a sleep and then actually do the video or whatever else, right? So by midnight we want to have the video as well, but we want to de-stress that whole element, so you don't have, you know, half an hour to the deadline. You still need to get you know, few minutes video together, and including editing and all that kind of stuff. So 2 deadlines, yeah, okay. Do you want to have prefer one deadline for everything? No.
Yeah. Yeah, the later one.
The later. Good. So actually give it to you based on that. Anyway, no. So yeah, so that's the rough idea basically. So you have until Monday noon, and it should start very soon, anyone now. So yeah, feel free to read this information. The exam resources should be available. The graphics assessment form looks like that. So you enter your student identifier there. Again, not the number, your identifier, the FIDE login basically. I think that's what you use, right? And then fill all that stuff. Yeah, please.
So is that then the username or the entire mail, like at student?
Not the mail. I want the identifier. I want the identifier, the one you use. Yours starts with an M, for example, right? So, right. So, but not this number. If we have to enter student number, it's very hard for us to find actually. We have some references here and there to it, but having a uniform identifier makes our life so much harder, especially we realized it in the project marking. Cool, I switch off the stream right now. The reason is that I want to go back to the submission spreadsheet, but that's just pretty much everything I wanted to run over with respect to the exam.